this mail message. So at that point, I'm pretty much stuck. I've got two options. I can come into my cart should method and I can start doing things like creating a fake SMTP message. I can go into my order and I can say something like, if I'm in test mode, don't actually send my message. There's various hacks I can do to try and get around this. There's even a handy tool that you want to use sometime called SMTP for Dev that you can use. You can download this from Codeplex actually, and it'll sit there and listen on port 25 on your dev machine. And then if you go and run tests like this one, you'll see it flashes and shows you the message that you received. So here's my order details, for instance. And if you completely shut it down, minimize it, and rerun your test, it'll pop up a little toast message here that shows you that a message was received. So this will still let you test your emails with this particular thing. And similarly, if this were database access, I could write some kind of a test database that I could use. If this were talking to my payment gateway supports some kind of fake credentials that I can pass it that'll give me back some kind of data. There's all kinds of ways that I can do some sort of integration test that really does use the implementation that I expect to use in production. But having to put together and glue together all this infrastructure just to be able to test the logic of my order, to be able to say that, really I just want to know that when notify customer is true, that this notify customer method is called. I don't care about the details of it. I don't care if it's notifying him with an email or an SMS text, or if somebody's running down the hall to let them know that their cart happened to have been processed. I just care that when that flag is set, this method is called. And right now, because of the tight coupling of the order class to these dependencies, the mail message and the SMTP client, I have no way of testing that. And that's causing me a lot of pain when I want to be able to write some tests to show that this is really doing what I expect it to do. The problem with our order class is that it has a lot of hidden dependencies. It's depending on mail message, SMTP client, the inventory system, the payment gateway, a logger, and datetime.now. And the result is that we have a class that has very tight coupling. There's no easy way to change any of these implementation details, so this is an open-closed principle violation. The only way we can change how order works is to go in and actually change its code. And it all ends up being very difficult to test. So let's talk about a particular technique that we can use to make this easier. Dependency injection is a technique that's used to allow calling code to inject the dependencies that a class needs when it is instantiated. This also goes by the term of the Hollywood principle, which is basically, don't call us, we'll call you. So instead of our class calling SMTP client, it could say that it needs some kind of notification service that knows how to do notification, and it will go ahead and call that, but it doesn't need to instantiate it itself. Now the term dependency injection, or DI, has three primary techniques that I want to talk about here. The first one is constructor injection. The second is property injection, or setter injection. And the third one is parameter injection. There are other methods that exist both for dependency injection as well as to solve the general problem of the dependencies that exist when a class knows about the things that it's newing up. One of those is called service location. But those are beyond the scope of this particular module. So the first type of dependency injection is called constructor injection. And this is an instance of the strategy pattern, which is a very popular design pattern. It's extremely useful in object-oriented programming. With constructor injection, dependencies are passed in via the constructor. The constructor then is being honest with the things that call it, in that it is explicitly stating the things that it needs in order for it to be in a valid state and to be able to do the work that it expects to be able to do. The pros of this approach are that classes self-document what they need. It works well with or without a container, and I'll talk more about containers in a moment. And classes are always in a valid state once constructed. Some of the cons are that constructors can end up with a great many parameters. They have a lot of dependencies. which is a design smell in and of itself that needs to be addressed. Also, some features, for example, serialization, may require a default constructor, for example, a parameterless constructor. So even though you may have a constructor that explicitly specifies all of the things that your class depends on, for reasons like the need to use serialization, you may also still have to expose a parameterless constructor that doesn't have those things set up. Also, some methods in the class may not require things that other methods require. So placing those dependencies into the constructor effectively makes all of the methods require all of the dependencies. This is also a design smell because if you have methods in your class that don't require certain things and other methods that do, it's likely telling you that your class lacks cohesion, and it would be wise for you to refactor it into multiple classes that share dependencies and share, common tasks. Another type of injection is property injection, which is also known as setter injection because you set the thing that you're injecting using the set method on the property. Some of the pros are that the dependency can be changed at any time during the object's lifetime, and thus this is very flexible. However, one of the cons is that objects are in an imbalanced state between construction and the setting of dependencies via setters, unless the constructor calls the setters. And it also can be less intuitive because there isn't any one place that you can go on that class, short of reading the documentation, that tells you exactly the properties that need to be set and perhaps the order of setting those properties in order for the class to ultimately be usable by the client calling code. And then the third method is through parameter injection. In this case, the dependencies are simply passed in as a parameter to the method. This is the most granular, it's very flexible, it does not require any changes to the rest of the class. However, some of the cons are that this breaks the method's signature. So if you have a method that's already in use by a great many classes in your application, some of which perhaps you cannot easily change, then breaking that method signature could be very expensive. Whereas adding another constructor that allows you to pass in this dependency might be something that you can easily do without breaking any of the existing code that depends on that method. Similar to with constructor injection, this can result in having many parameters on your method. But again, this is a design smell in and of itself and something that you should address in order to create a more cohesive design. You should consider using parameter injection primarily if you only have one method in a particular class that has a certain dependency. Otherwise, it's better, in my opinion, to use constructor injection because this is able to make very explicit to anyone using your code what exactly it needs in order to function. When we refactor our example class, the things that we're going to do in order to apply the dependency inversion principle are to extract the dependencies out into interfaces and then inject implementations of these interfaces into the order. As a side thing, we'll also reduce order's responsibilities by applying the single responsibility principle, but we're going to just gloss over that as that's a separate module in and of itself. Let's look back at our solution, our order object. The order object has a number of dependencies that we need to extract. And we're going to do this by applying the strategy pattern and using something called constructor injection. So in order to do constructor injection, the first thing we need is a constructor. So we'll add that. And we can take some of the things that are common throughout the entire class that are currently parameters on checkout and move these into our constructor parameters as well. So for instance, we could say that our order requires a cart, and then we can turn that into a field that we can use elsewhere. Likewise, we could say that we always have to have payment details, so we'll add those as well, and make that a field too. And the next thing we need to do is take some of our dependencies and convert those into interfaces that we can inject. So the first one that we see here is notified customer, and so we can simply take this exact signature and make that our interface. So we're going to say that we have a void notify customer. We'll come up here, we'll just create a new interface in the same class for now. We'll call it I notify customer for now. and you see it takes a cart in order to do its work. If we look at this, we're going to see that the cart has the customer email, and pretty much it looks like everything else it needs is here. Now, the notify customer implementation might need to take in an iLogger or something at some point, but for now we can do what we need with just this simple interface, I think. So once we have this interface, let's go ahead and create a derived type for it, and we'll just do this right here, and we'll call this notify customer service. And of course we want to implement members, and so we have a notify customer, and we really just want to take this whole method out of here and place it into here. And at that point we have this notify customer service that we could use. If we come back into our constructor, we can then pass in our notify customer and pass that in as well. And now it's just a matter of wiring up these fields so that they are using the fields instead. So if we come in here and change notify customer to be underscore notify customer dot, now that's going to go ahead and call our notify customer method on our interface. We've eliminated the dependency within order on anything having to do with SMTP. Now we'll see in a moment how we can repeat this same process in order to pull out the dependency on the inventory system and dependency on our charge card. So let's look at our class dependencies as they began with our order class. And you can see that order class had strong dependencies on the payment details, the payment gateway, the inventory system. There's also, not shown here, dependency on the system.net classes that are doing SMTP stuff. Now I've gone ahead and done all this refactoring already inside of the loose coupling folder here. You can download this code and go through this yourself. The online order is something that currently does the work of everything that you would expect for an online version of the order that needs to do notification as well as credit card processing and inventory reservation. In the single responsibility principle video, we looked at a couple of other alternatives to order. For instance, if it was a point of sale order, you might not need to do a notification service because the customer is standing there and they know that they made their purchase. But in this case, we're talking about online orders. We identified these 4 fields that we wanted to pass, in addition to the cart, which is being passed in on the base class of order through its constructor. And finally, with each of these interfaces established, we also create default implementation. So the notification service looks like the one that I just showed you, and also a payment processor and a reservation service that are simply cut and pasted out of what was there previously. So looking at online order, we can see that the entire class is now only 36 lines of code, and it's very easy to follow. You can also see that the new keyword does not exist anywhere in here. This class now takes in all of its dependencies through its constructor, making it very easy for us to test the class through the use of fake implementations. So let's look at what the tests would look like. So look at our first test here, where we want to send the total amount to the credit card processor. We want to verify that whatever the cart amount is actually what we're going to charge the user's credit card. So for this, we're going to create fake implementations of each of our dependencies. We have a fake payment processor, a fake reservation service, fake notification service. And we have a cart with $5.05 in it. That's a payment type credit card. We create our order and check out. Once we check out, we want to check 2 things. We want to verify, first of all, that our payment processor was called at all. And then we want to verify that our payment processor had the correct amount passed into it. We're going to compare that with the cart total amount. Now, our payment processor interface does not support what's called or amount passed. If we go look at iPayment processor, we'll see that the only method it's